In this lesson, we're going to talk about linear regression. We're going to define it, and then we're going to show you how to use the calculator to do linear regressions. We're going to talk about what the numbers mean that you get out of the linear regression, and then we're going to use it to estimate. First, what is it? Linear regression is a method used to find the line of best fit given a set of data. This can be done through your graphing calculator or other technology softwares, and will create the most precise equation possible. So what we have here on this screen is a picture of a data set, and it's a bunch of dots on the screen, and the line that goes through them is the one that fits them the best. Now there's not going to be one single line that goes through all of the data. You just want to pick one line that fits it the best, and that's what we're doing today. So here's an example of a question. The data in the table shows the average temperature in northern latitudes. Find the line of best fit and estimate the average temperature for a city with a latitude of 48 degrees. Now, when I see this in my head, I think of a question like, as the latitude increases, so as we go north, does the temperature get colder? As we go south, does the temperature get warmer? And we kind of instinctively know that as we go closer to the equator that the temperature does get warmer, but we can actually see that with data. And we can look at it if we plot the latitude of 0 degrees and then the temperature of 79 degrees, and then we pair 10 with 81 and we plot over to 10 up to 81 and over to 20 and up to 79, we can see if there's a trend to the data, and then we can see if there's a line that fits that data the best, and then we can use that to estimate other latitudes. So to do this, you're going to use your calculator. So first, on your graphing calculator, you're going to press Stat and then Enter to enter the data. You're going to enter the X values in L1 and the Y values in L2. Now it's important to know that you use the Enter button to go down to the next entry, and then you use the arrow button to go over to L2. If you want to clear it, you can highlight each data element and hit delete. Do not clear, don't go up here and hit delete though, because that's going to delete the entire list, including the L2, and it'll disappear. We can get it back, just don't do that. Okay, now we've got it in our calculator, we've got the data in our calculator, now we want to find the line of best fit. So to do that, we go to Stat, you go over to Calculate, you choose number 4 for LinReg, which stands for linear regression, and it's the one that says AX plus B. It should look familiar to you, like MX plus B, and then you hit Enter 5 times. And that'll eventually get it to calculate. And you'll see this on your screen. Hopefully you're doing this along with us. If not, rewind, put the data in, do it along with us, and you'll get this answer. And what we just found was the equation of the line that fits this data the best. So these dots represent 079 is right here. You can hardly see it. 1081 is right here. 2079 is right here, and so on and so forth on this scatter plot. And what we just found was this equation of this blue line right here that fits the data the best. It goes through some of them, it looks like. Some of the points are above the line and some of them are below the line, but it fits it the best. And we're going to talk more in a future lesson about, there's an actual measurement called the correlation coefficient that tells you how good your line of best fit is. We're going to talk about that in a future lesson. So now, what do these numbers mean? So what we just found is that A is negative 1.07, so that's our slope, and 92.86 is our y-intercept, that's our B. So this is what the equation looks like when you write it out as an equation. Y equals negative 1.07x plus 92.867. What do those numbers mean? They have meaning in the terms of our variables up here. Negative 1.07 means, actually let's start with the y-intercept. The y-intercept means that according to our model, at 0 degrees latitude, which would be the equator, the temperature is about 93 degrees. Now, we actually clocked it at 79, but according to our model, it's 93. Because remember, it sort of fits our data, but not perfectly. So we're starting at 93 degrees at the equator, and then for every increase in latitude, degree increase in latitude, the temperature decreases 1 degree. For every increase in latitude, the temperature decreases a degree. And we know that as we go further and further and further north, once we're up to 80 degrees latitude, the temperature is only 1 degree there. That's what those mean in terms of the context of the situation. Now, one of the beautiful things about the purpose of this is that we can use it to estimate values. Now, you want to be very careful. We can estimate between 0 and 80 degrees. After that, we might be able to predict about 85 degrees or 90 degrees, but we're not going to be able to extrapolate this, predict this out to a much larger number or a much lower number than is what is actually indicated in the data. The further you get away from the data that is collected, the less precise that your estimation is. So keep that in mind. But here's our equation, negative 1.07x plus 92.867. I probably want to use as many decimal points as I possibly can. And I'm going to estimate 48 degrees latitude. So that's my x. So I'm going to put 48 in here, and then you just calculate that. And that's going to give you a good estimation, as good as we can get anyway, with this data, of what the temperature would be at 48 degrees latitude. And I just type that into my calculator, and the answer is 41.507 degrees Fahrenheit. And you can look at your table here and see that 48 falls right here. So it would make sense that my latitude would fall between 40 and 50. And that is linear regression and how you use it to estimate.